Good day everyone. Our group is going to present topic aggregates. Yan, ano nga ba yung objective ng report namin? First, to be familiarized with the aggregates and its importance and use. Next, to introduce one of the building blocks in building constructions. First, sa history muna tayo. People have used sand and stone for foundations for thousands of years. Significant refinement, the production, and use of aggregate occurred during the Roman Empire, which used aggregate to build its vast network of roads and aqueducts. The invention of concrete, which was essential to architecture utilizing arches, created an immediate permanent demand for construction aggregates. Yun, 'di ba, nung sa dati, yung mga Roman Empire, ang binibuild nila na roads is sobrang titibay, sobrang kakapal yung layer. Parang nagle-layer sila nung parang yung aggregates yung mga graba, tapos may mga nilalagay pa sila na layer ng stones, tapos bago yung pinaka-concrete or yung sa pinaka-soil para maging matibay yon. Kaya ngayon, yung iba sa mga construction nila, yung mga infrastructures nila is na visible pa rin hanggang sa present. Aggregates have been around since before humans walked the earth, formed in the fires of volcanoes and molded by erosion, time, water, and glaciers. The Romans were excellent engineers and used rock and concrete in almost everything they built, from aqueducts and bridges to roads and buildings that are still standing today. In almost every country in the world, you can find ancient structures that used some form of aggregates. Yan, bago pa raw yung civilization or yung existence ng tao, nandito raw yung yung aggregates. Yung mga bata na yun is parang product nung weather ng isang lugar tapos dun sa mga natural climate kaya nabibuild yung natural aggregates na pwedeng gamitin for constructions. Then since 'di ba mga magagaling in construction like parang sa engineers yung mga Roman, sila yung parang pinaka nakilala sa paggamit nun kaya matitibay yung mga infrastructures na binibuild nila. Aggregates in BC. In BC, the use of aggregate dates all the way back to the first Vancouver. The primary building material for the city was wood, but after the Great Vancouver Fire of 1886, new commercial structures were built from brick and stone to withstand fire. This was the start of strong construction industry in the lower mainland. Yan, 'di ba dati, ang pinakagamit talaga is yung sa sabi dito yung gamit talaga nila is wood for construction. Eh, nagkaroon ng fire nun, yung Vancouver Fire noong 1886. Tas start nun, dahil nga mas kailangan nila mas matibay para resistant dun sa fire, gumamit sila ng concrete, gumamit sila ng stones dun sa pagbibuild ng infrastructures nila. And aggregates became the primary building commodity. The two oldest commercial buildings in Vancouver were built after the fire of 1886. Yan, yung dalawang oldest commercial buildings na na-build after nung fire doon, na ang ginamit na nila is mga stones, aggregates, concretes. First, the Ferguson Block at number 2 Powell Street and the Byrne Building, located across the street at Water and Carroll, the site of Gussie Jack's original saloon. Aggregates the building blocks of civilization. Without the sand, stone, and gravel used in our infrastructure, modern society would simply not exist. Well, today, we use heavy-duty aggregate equipment and portable plants to produce and recycle aggregate material. Ancient civilizations did much of this work by hand. The fact that some structures have lasted over 5,000 years is a testament to the astonishing engineering knowledge and work of ancient people. Yan, yung aggregate daw is building block of civilization. Parang in every construction, parang required or kailangan talaga na mag-include ng aggregates, ng mga stones. Tapos, para mas maging matibay yung pinaka-foundation or yung pinaka-building na gamit nila. Then, yun, ang proof nga nun is yung matatagal na infrastructure na nakabuild hanggang sa ngayon na gawa pa nila. Tapos yung ano, kasi dati, 'di ba, ang ginagamit lang nila talaga is wala pa talaga mga equipment. Mano-mano 'yun. It's either sa hand nila or yung mga simple equipment lang na pinaka ginagamit nila. Pero wala pa talaga yung pinaka equipment for construction or for production ng aggregates. Kaya by hand yung gamit talaga nila nun. Tapos yun, dahil nga doon, parang mas naging pino yung paggamit nila. Mas naging mapino yung paggamit nila ng mga aggregates, mas naging effective. Kaya yan, matitibay yung mga na-build nila yung infrastructure. Next. Early signs of aggregate use. Some of the earliest signs of aggregate in use are from Mesopotamia around 3000 BCE. Ancient Mesopotamians built houses made of strong stone with simple concrete floors and even underground waterproof systems. This was one of the reasons they were able to thrive in the hot desert climate. Some of these structures have survived to these days. Yan. Doon sa early signs of aggregates daw, yung sa ancient Mesopotamians, sila daw yung parang nag-build nung nila, infrastructures nila, parang houses, shelters nila para dun sa pang-protect nila dun sa hot tsaka cold weather na nararanasan nila yun. Tapos, dahil nga gumamit sila din ng stones, ng aggregates, yung iba dun sa mga infrastructures na binil nila is nakasurvive hanggang sa ngayon. Parang hindi na siya nagalaw, nandun na siya, tapos hindi na siya nasira. Yun. Aggregates in ancient Egypt. Ancient Egyptians had access to an abundance of stone above ground. This ancient society used limestone, sandstone, and granite to erect some of the most iconic buildings on the planet. Diba, isa rin yung mga Egyptians sa kilala sa pagbibuild, like yung pagbibuild nila nung pyramids, tapos yun sa mga structures nila. Tapos sabi dito, sila daw may pinakamaraming access dun sa stone. Since gumagamit na sila ng pinaka-stone nun sa infrastructures nila, marami din sa mga na-build nila like sa pyramid is nag-exist hanggang sa ngayon. Parang visible siya sa ngayon. Although hindi siya yung pure na aggregates kasi yun, mga stones yung gamit halos nila yun. Pero merong doon, traces na gumamit na sila ng aggregates nun. Parang fine stones nun or granular stone pang fill doon sa ibang part ng foundation ng mga infrastructures nila. What is an aggregate? Aggregates are coarse, particulate rock-like material consisting of a collection of particles ranging in size from 0.1 mm to 50 mm. Types of aggregates include coarse aggregate and fine aggregate. It is also a broad category of coarse to medium-grained particulate material used in construction including sand, gravel, crushed stone, slag, recycled concrete, and geosynthetic aggregates. Yung aggregates daw is yung para mga pinong bato, hindi siya yung mga buo-buo. Parang nasala na ng mga bato, tapos meron siyang range ng size niya, pero dapat hindi siya sobrang lumaki kasi siya yung pinang sinasama dun sa foundation, sa mixture ng concrete, panglagay sa foundation sa infrastructures. Kaya hindi pwedeng maging malaki masyado yun sa pinaka-diameter ng mga aggregates. Tapos siya din yung pinaka nagdadagdag nung sa tibay nung sa concrete, yan. Aggregates are a component of composite materials such as concrete and asphalt. The aggregate serves as the reinforcement to add strength to the overall composite material, along with the water and Portland cement that are an essential ingredients in concrete. Yan, yung sa concrete nga, 'di ba? Hindi naman siya kadalasan kapag concrete lang mismo is parang magiging hindi siya ganoong katibay kapag inirely-rely siya dun sa foundation o kaya dun sa magke-carry mismo ng load ng infrastructure. Applicable lang siya dun sa mga hindi masyadong affected ng loads. Tapos dun sa pinaka pang-fill dun sa building. Pero most likely dun sa foundation, dun sa flooring, sa kung saan may ma-receive na load yung building or ma-expose sa load or sa environment. Mostly naglalagay talaga sila ng aggregates doon kasi nagdadagdag siya nung strength doon sa building, strength doon sa concrete. Dinadagdagan niya yung parang pinakatibay ng concrete. Instead aside sa paglalagay lang nung cement at saka nung sand, kailangan naglalagay din talaga ng aggregates. Then next na i-report is yung importance ng aggregate.
So, bakit nga ba importante ang aggregate? So, importante siya kasi binubuo niya yung 60 to 75% ng volume ng concrete. Mas pinatitibay niya, ginagawang mas compact at water resistant yung concrete. Mas pinapababa niya pa yung production cost. So, nagko-contribute siya sa mechanical strength ng concrete. Gaya ng sabi kanina, mas ginagawa niya compact yung mix. Tapos, pwede din gamitin pang filter sa tubig or as fill material. So, unang common aggregate ay crushed stone. Ginagamit siya sa kalimitan ay sa macadam roads at saka sa mga railroad. Pwede din siya gamitin na panghalo sa concrete, tarmac, and asphalt concrete. So, saan nga ba galing yung crushed stone aggregates? So, nakakuha tayo ng crushed stone aggregate sa pagdurog ng mga na-extract na mga igneous, sedimentary, or metamorphic rocks. O kaya, pwede naman nating durugin na lang yung mga quarried rocks, tapos salain natin para makuha natin yung tamang size. Tapos, ito yung tatlong stages ng production ng crushed stone aggregates. Una, yung primary crushing, para yun sa mga sobrang lalaking bato, para magkasya sila sa mga machinery, or basta para lang mapaliit, para mas madali sila i-manage. So, secondary and tertiary, para lang yun sa mga, para makuha natin yung tamang size nila. Tapos screening, para na yun sa mga finished product. Tapos sunod, gravel. So, ang gravel, ginagamit siya sa paggawa ng construction materials. Panghalo sa asphalt, sa foundation ng mga kalsada, sa buhos, at iba pa. So, pwede nga ang gravel ay mabuo sa weathering or erosion ng rocks. O kaya naman ay nakukuha sa gravel pits kung saan dinudurog yung mga bato hanggang sa maging ideal yung sizes nila. So, other uses ng gravel, minsan ang gravel ay tinutunaw tapos papatigasin uli. Yun yung gagamitin na aggregate sa construction. Pwede din na yung nilalatag sa lupa kasi nakukulong niya yung moisture sa ilalim niya o minsan pampaganda lang talaga ng bakuran. Tapos sunod naman ay buhangin. Ang buhangin, makikita natin siya sa paligid. Tapos gawa siya sa mga maliliit na bato-bato dun sa lugar kung saan siya na-form. Ginagamit siya sa construction at paggawa ng concrete. Tapos isa siya sa mga pinakamahalagang bagay sa construction, pwede gamitin sa kung ano-anong klaseng mga project. Siya din daw ay nag-a-act as skeleton o filling ng concrete. Tapos ito, kinds of sand. Una, yung river sand, syempre makita natin sa ilog. Tapos ayan, gaya na nasa peak, maputi, tapos medyo mapino siya. Tapos sunod, yung concrete sand naman, yung nakikita natin madalas sa mga construction, yung kulay gray na buhangin, yun, ganun. Tapos fill sand, yung combination siya ng mga fine aggregates, mga bato o lupa na dinurog hanggang maging pino. Yun, ganun siya. Tapos yung coarse sand naman, yung buhangin na medyo may kalakihan kumpara sa ibang mga kinds ng sand, yung size ng grains niya. Utility sand, yun yung parang iba-iba yung kulay ng grains, tapos medyo may kalakihan din yung size ng grains niya. Tapos pit sand naman, madalas ginagamit sa building kasi maganda yung binding property niya, red-orange yung kulay niya. Yun. Tapos fine sand, ginagamit siya sa pangpalitada kasi sobrang pino ng grains niya. Nagiging sobrang smooth ng surface, gano'n. Tapos M sand, ibig sabihin lang yan ay manufactured sand, yun, galing sa mga factory, gano'n. Tapos sunod naman, lightweight aggregates. Ito naman, nasa pangalan na niya, yung mga aggregate na mas magaan pa kaysa sa ibang ibang aggregates, gano'n. Pero di naman ibig sabihin nun, di na ganun katibay yung mga gawa sa LWA kasi ang LWA ay ginagamit pang gawa ng mga high strength concretes. Tapos merong mga natural aggregate na magaan talaga pero pwede mo din siya gawin mula sa slag o kaya fly ash. Tapos ginagamit syempre sa paggawa ng lightweight concrete products. Tapos kalimitang ginagamit na LWA ay diatomite, pumice, vermiculite at saka perlite. Tapos ito, types of LWA. Una is industrial waste LWA. Yun yung mga gawa sa fly ash, slag ball, cinder, light sand, natural. Tapos natural LWA naman is yung mga kagaya nung diatomite, pumice, vermiculite, tsaka perlite. Tapos artificial LWA, yun yung mga gawa na sa local materials. Parang mga, minsan clay, ganun. Tapos sunod, recycled concrete aggregates or RCA. Ayan. Ang RCA ay gawa sa mga concrete na dinurog mula sa demolition projects. Yun, mga nirecycle nga. O kaya pagka merong mga binabago sa building, tapos merong mga tinitibag, yun, dun siya gawa. Kasi, so, yung mga dinudurog na mga concrete kasi sa mga dinemolish na building, sinasala pa, inaalis yung mortar, tapos yung mga bato na makukuha nila, yun yung pwedeng gawing RCA. Tapos ang pinaka-optimal lang daw na ilagay na RCA sa mixture ay 35%. Pag din daw lumabas kasi sa 65% yung volume ng RCA sa mixture mo, pwede magpahina ng sobra sa concrete. Tapos ayun, sunod naman, benefits ng RCA. So, benefits ng RCA naman, syempre dahil recycled, mas pinapamura niya yung cost ng construction. Tapos mas papababa niya yung environmental impact kasi di na nga natin kailangang itapon kung saan man yung mga natibag nating concrete. Tapos dahil doon, mas mape-preserve natin yung mga natural resources, mas makatipid tayo, ganon. Mas makabawas sa space na gagamitin para sa landfill kasi ayun nga, may pangdagdag na tayo sa panggawa natin ng landfill. Tapos yung risks naman, ayun gaya na sabi kanina, kapag naman sumobra ang gamit natin ng RCA, pwedeng makabawas sa structural integrity. Tapos magkakaroon siya ng cracks agad, ganon. Tapos di din siya, um, dapat lagi din siya nire-refine. Kasi pwedeng yung mga ma-recycle natin, mga brittle na aggregate, tapos magkakaroon yun ng uneven grading pag ganon. Tapos kailangan din daw, pag gagamit ng RCA, dadagdagan pa ng supplement yung mix para maging kasing tibay siya ng parang gumamit ka lang ng normal na aggregate. Tapos syempre, pag nagre-refine, kailangan mong bantayan yun para sure ka na yung mga magagamit yung RCA ay okay, ganun.
Hi, my name is Diana Rose Cabanatan at ako po ang magre-report sa extraction of aggregates. Bago ko simulan yung pagre-report, kailangan muna natin i-define kung ano nga ba yung quarry. So sabi dito, it is a place or large deep pit from which stones and other materials are being extracted. So ayun, yung mga aggregates nga na yung mga bato, yung mga sand and gravel. So ayun, sa quarry nga daw po nakukuha yun. Next, ayan, how a rock quarry works. So dito malalaman natin kung paano kinukuha yung mga rocks tapos kung anong process nila. Dito, rock quarries usually operate for at least 30 years and are developed in distinct benches or steps. Ang controlled explosion is normally used to release the rock from the working phase. It is then transported by truck or conveyor to a crusher, where it is goes through a series of crushing and screening stages to produce a range of final sizes to suit customers' need. Ayun nga. Sa rock quarries, nagpapasabog sila ng controlled lang naman para magkapira-piraso yung mga rocks. Sa rock quarries kasi yung place niya puro bato-bato, yung mga malalaking bato. Kaya kailangan nilang magpasabog para maging mas pira-piraso yung mga rocks. Tapos, yung excavator, hinahakot nila yon tapos nilalagay sa isang truck. Tapos yung truck naman, dinedeliver nila sa planta. Tapos ilalagay sa crusher. Tapos ayun, doon na nila ini-screen, nililinis para mabenta sa market. Ano nga ba yung crushing? Powerful hammers or metal jaws within the primary crusher break the rock down. Rock passes through a series of screens that sift it in different sizes. It may also pass through further crushing stages. Yung kasi, yung pagka-crush ng rock, may 3 stages yan. First na stages ay yung primary crushing. Yung mga rocks doon, nire-reduce yung sizes and shape nila para ma-handle ng secondary crushing. Sa secondary crushing naman, nire-reduce nila into standard sizes para yung mga binibenta sa market ganun. Binabawasan nila sa ganung size. Tapos yung final reduction crushing naman, ayun, parang pinapolish na lang nila yung rock kung tama ba yung mga sizes na kinat sa secondary crushing. Tapos ayun, dinedeliver na sa market para mabenta. Next, kung kanina sinabi ko yung process ng rocks, kung paano siya pinoproseso, dito naman aalamin natin kung paano yung pagpaprocess ng sand tsaka gravel. How sand and gravel quarry works. Sand and gravel quarries are much shallower than rock quarries and are usually worked and restored in progressive phases. Ayun nga. kung kanina sabi ko yung rock quarries, bato-bato siya. Sa sand and gravel quarries naman, shallower, tapos nakalocate siya sa river, sa lake, sa seabeds. Tapos, ayun, mas maraming mga lupa, tsaka gravel. Tapos, these are pumped to allow them to work dry or operated as lakes with extraction below water. Tapos, yung excavator ulit, naghuhukay siya ng lupa sa sa mga seabeds, ganun, or pwede ring sa lakes. Parang nilulubog niya yung bucket ng excavator. Tapos, dinadala nilalagay ulit sa truck. Tapos, yung truck naman, dinadala ulit sa processing plant. Ganon. Tapos, pagkalagay sa processing plant, dito naman pinaprocess yung sand. Parang nililinis siya, tapos tinatanggal yung mga unwanted clay, tapos isi-separate sa sand, kasi yung sand lang naman talaga yung kailangan. Tapos, kunyari, na-separate nalinis na yung mga sand, nilalagay siya sa isang place, tapos pinapatuyo dun, ganun, bago dalhin sa market. Yung gravel naman, sabi dito, it passes over a series of screens to to separate different sizes of gravel. Ayun nga, pinagsasama-sama yung mga different sizes ng gravel kasi iba-iba nga yung mga sizes niya. Tapos pag magkakasama na yung mga magkakaparehong sizes, nilalagay din sila sa isang place. Tapos ayun, dinideliver na ng mga truck sa market. Next, yung marine aggregates naman. Kung kanina, rock yung pinag-usapan natin. Tapos, sand and gravel quarries. Dito naman, marine aggregates. Kailangan muna natin i-define kung ano nga ba yung marine aggregates. So, marine aggregates is naturally occurring sand and gravel. The geological origin and mineral composition are the same as land-based sand gravel. Ayun. Kapareho lang din siya ng sand and gravel na nakikita natin na sinabi ko kanina nakikita sa sa seabed, sa river, sa lake. Ayun, kapareho lang din siya. Ano nga ba napaprocess yung marine aggregates? Saan nga ba ito nakukuha? At paano nakukuha? A significant proportion of the demand for aggregates is satisfied from river, lake, and seabeds. Our marine resources are an increasingly important alternative source of aggregates. Marine aggregates play an important role in replenishing beaches and protecting coastline from erosion. Kanina, na-discuss ko na yung sand and gravel quarry nga ay madalas nasa river sila, nasa lake, nasa seabed. Ang downside kasi nun, parang nakakalbo kasi yung mga sand doon, pumapangit yung mga beaches natin, gano'n. Tapos, pag umulan ng malakas, madalas kasi bumabaha doon. Tapos, ayun nga. So, nag-isip sila ng alternative para magkaroon pa ng ng sand and gravel. So, ang naisip nila, marine aggregates. Kumukuha sila ng aggregates sa ilalim ng dagat. So, ayun. Sinabi lang dito sa pangalawang paragraph yung kung paano nga ba nakukuha yung marine aggregates. Sabi dito, pag nasa dredging area na sila or yung kung saan kumukuha ng sand and gravel using satellite navigation, yung vessel, binababa nila yung pipe hanggang sa makarating sa sa sand ng dagat. Tapos kapag nakarating na, it's either magpo-forward or backward yung vessel habang hinihigop ng pipe yung sand and gravel papunta sa sa lalagyan ng vessel hanggang sa mapuno to. Tapos ayun, dredge material is discharged at wharves and other marine facilities where it is processed, screened, and washed as required. Ayun, dinadala yung mga aggregates na nakuha nila sa sa marine facilities. Tapos ayun, nililinisan din sila. Tapos ini-screen. Parang katulad lang din sa pag-process ng sand and gravel na diniscuss ko kanina. Ayun, yun lang po yung i-discuss ko. Thank you po.
So, this is the second part of our report. So, ayan. Sa first part, diniscuss yung history of aggregates, in-explain kung ano yung aggregates and yung mga common types na ginagamit, and yung extraction of aggregates. So, here, sa second part, we will be discussing the classification of aggregates based on its shape and size, the properties of aggregates, and the list of test methods for concrete aggregates. So, ayan. Before tayo mag-proceed, padaanan muna uli natin tong benefits or importance of adding aggregates on concrete and asphalt, since na-discuss na rin naman siya sa first part. So, ayan. Adding aggregates on concrete and asphalt makes the concrete mixes more compact. And, ayan, aggregates lower the consumption of concrete of water as well as the production cost. And, aggregates add to the mechanical strength of the concrete or asphalt and decrease the permeability of concrete and increase its water resistance, and aggregates modify the heat retention values of concrete. So, ayan. Classification of aggregates based on its shape. So, meron tayong 6 dito. First one is the rounded aggregates, irregular or partly rounded aggregates, angular aggregates, flaky aggregates, elongated aggregates, and the last one is the flaky and elongated aggregates. So, ayan. First one is rounded aggregates. So, rounded aggregates are naturally occurring aggregate, and they are fully water-worn or completely shaped by attrition. So, kapag sinabing attrition, yung mga bato sa ilog or sa river, when they knock against each other, they break apart into, and ayun, nagiging mas maliit sila and nagiging more round. So, rounded aggregates are the main factor behind the workability. So, itong workability, ito yung term na ginagamit to describe how easily freshly mixed concrete can be placed or can be mixed, and ayun, kung gaano siya kadali mahalo, yung ganon. And also, ito yung property na it directly impacts the strength and the quality and the appearance of concrete. So, ayan. So, rounded aggregates yung main factor behind the workability. Since, rounded aggregates, kasi, they have the minimum percentage of voids, which is 32 to 33% lang. So, ayan, kaya nagre-result yun sa greater workability. Though, siya yung main factor behind the workability, hindi pa rin siya kino-consider for, high strength concrete because of, poor interlocking behavior niya, and, may weak bond strength siya. So, ayun, weak lang yung bond strength na meron siya, pati yung, interlocking behavior is poor. So, ayan, examples nito, ayan. So, next one, irregular or partly rounded aggregates. So, it is partly shaped by attrition then, but not fully rounded. And, ayan, so irregular aggregates may result 35 to 37% of void. So, ayan, so it will require more cement paste. And compared to rounded aggregates, since mas mataas yung percentage ng void niya, ay meron siyang lesser workability. So, hindi ganun yung workability niya. So, ayan, the bond strength is slightly higher than rounded aggregates suitable for making ordinary concrete, but that is not enough for high strength concrete. So, examples, ayan, pit sands, cuboid rocks and gravels, land and dug flints. So, ayan, third one, angular aggregates. So, angular aggregates consist of well-defined edges formed at the intersection of roughly planar surfaces. So, ito yung yung karaniwan nating nakikita. Yung may medyo matulis na mga bato-bato. So, ayan. Angular aggregates are obtained by crushing the rocks. So, unlike yung sa mga nauna na na-form siya by attrition, ito naman by crushing the rocks. So, ayan, angular aggregates result maximum percentage of voids from, ayan, 38 to 45%. So, kung yung rounded aggregates, yung may minimum percentage of voids, ito naman yung ito yung may maximum percentage na, ayan, 38 to 45%. So, siya yung, nagbibigay ng, yung may less workability compared dun sa dalawang nauna. So, ayan. Pero kahit na ganon, ayan, they give 10 to 20% more compressive strength due to development of stronger aggregate mortar bands. So, ayan. Siya? Ito na yung ginagamit for manufacturing high-strength concrete. So, ayan. Example, crushed rocks of all types. So, ayan. Next is the flaky aggregates. So, when the aggregate thickness is small when compared with width and length of that aggregate, it is said to be flaky aggregate. Or in the other hand, when the least dimension of aggregate is less than the 60% of its mean dimension, then it is said to be flaky aggregates. So, tawag dito, yung flaky aggregates, yung mas manipis siya, yung manipis lang siya na aggregates compare mo dun sa mga naunang nabanggit. And, flaky aggregates increase the surface area in a concrete mix, so, magre-require siya ng more cement paste. So, ayan. Example, laminated rocks, both naturally occurring as well as crushed. So, ayan. Ito na. Elongated aggregates. So, elongated aggregates are longer than they are thick or wide. So, when the length of aggregate is larger than the other two dimensions, then it is called elongated aggregate, or the length of aggregate is greater than 180% of its mean dimension. So, tulad nung flaky aggregates, nag-a-add din siya ng more surface area sa mix. So, ayan, more cement paste then is needed dito pag ito yung ginamit. So, last one, flaky and elongated aggregates. So, when the aggregate length is larger than its width and width is larger than its thickness, then it is said to be flaky and elongated aggregate. So, mix na siya ng dalawa. So, ayan, a mix of the previous two and siya, least efficient form of aggregate with regards to workability. So, ayan, kasi nga, diba, siya, tawag dito, yung bond between them is, stronger compared sa rounded, siya, tawag dito, yung void, yung percentage ng void niya is mataas. So, ayan. The above three types of aggregates are not suitable for concrete mixing. These are generally obtained from the poorly crushed rocks. So, ayan. The shape and the texture of aggregate affects the properties of fresh concrete more than hardened concrete. So, concrete is more workable when smooth and rounded aggregate is used instead of round, angular, or elongated aggregate. So, ayun nga. Yung mga smooth and rounded aggregates, 'di ba, mas mataas nga yung workability niya compared to rough angular or elongated aggregate. So, ayan. Most natural sands and gravel from riverbeds or seashores are smooth and rounded and are excellent aggregates. So, ayan. crushed, crushed stones, crushed stone, uh, crushed stone produces much more angular and elongated aggregates. So, and which have a higher surface to volume ratio. So, ayan, better band characteristics but require more cement paste to produce a workable mixture. So, ayun. The surface texture of aggregate can be either smooth or rough. And a smooth surface can improve the workability, gaya ng nasabi nga kanina, and yet a rougher surface generates a stronger bond between the paste and the aggregate, creating a higher strength. So, ayan. Next one is yung classification of aggregates based on its size. So, ipapresent yun ni Ben Joshua Mercado. So, ayan. Thank you.
Magandang umaga. Ako nga pala si Ben Joshua Mercado. Ang magre-report ng classification of aggregates based on its size. Aggregates are available in nature in different sizes. The size of aggregate are used may be related to the mixed proportions, type of work, and etc. The size distribution of aggregate is called grading of aggregates. Following are the classification of aggregates based on size. Fine aggregate, tinatawag natin yung fine aggregate na sand, yung maliliit na particles ng materials. And then coarse aggregate, ito yung stone. And then next, ito yung scope ng fine aggregates and coarse aggregates. Definition of fine aggregate are small size filler materials in construction, and then coarse naman ay yung larger size filler materials in construction. Size of particles of fine aggregates are the particles that pass through 4.75 mm sieve and retain on 0.75 mm sieve. Ganito kalalaki yung butas nung salaan, 4.75, and then nilalagay yung mga yung materials na example na lang sand. Kasi nasala siya hanggang matira na lang 0.075 mm. And then sa coarse naman are the particles that retain on 4.75 mm sieve. Ito nga yung matitira doon sa may taas, ito yung malalaking sa pagsasala, ito yung matitirang materials na, and then 4.75 mm yung laki. And then yung materials naman sa fine aggregate is yung sinabi ko nga, katulad na ng sand, turkey, stone screening, burn clays, cinders, fly ash, etc. are used as fine aggregate in concrete. Sa coarse aggregate naman, brick chips, broken bricks, stone chips or broken stone, gravels, pebbles, clinkers, cinders, etc. are used as coarse aggregate in concrete. Papakita ko mamaya yung materials na picture about sa sizes ng fine aggregates and coarse aggregate. And then source na pinagagalingan ng fine aggregate, river sand or machine sand, crushed stone sand, crushed gravel sand are the major source of fine aggregate. And then sa coarse naman, dolomite aggregates, crushed gravel or stone, natural disintegration of rock are the major source of coarse aggregate. And surface area naman ng fine aggregate is higher kaysa sa coarse aggregate. And then function ng fine aggregate sa concrete, voids between the coarse aggregate are filled by fine aggregates. And then coarse aggregate acts as inner filler material for concrete. And then uses naman ito, fine aggregate are used in mortar, plaster, concrete, filling of road, pavement, layer, etc. And sa coarse aggregate are mainly used in concrete, railway, truck ballast, and etc. And then next, ito ngayon makikita natin nung size of fine aggregates. Coarse sand, ganito kalalaki yung butil, parang bigas. And then medium sand, and then fine sand na mas maliliit kaysa dun sa medium. And then next yung silt, and then yung clay. And then sa size of coarse aggregates naman, fine gravel, medium gravel, coarse gravel, cobbles, and boulder. Makikita natin sa difference nung fine aggregates, parang size siya ng grain, or tinatawag natin parang bigas. And then sa fine gravel naman, mas malalaki yung nare-retain siya pag sinasala. And then next, properties of aggregates. The aggregates are used as important ingredient in the preparation of concrete. The fine aggregates are used in concrete as pillars, and the coarse aggregate gives the compressive strength to concrete. Makikita nga natin ang fine aggregates nga ginagamit sa concrete as pillar, and then coarse naman nagbibigay na compressive strength to concrete. But there are properties or characteristics of aggregate which influence the properties of resulting concrete mix. Then yung first, specific gravity. The specific gravity of aggregate is calculated by ratio between the weight of aggregates to the weight of water, which equals to aggregate weight. The high specific gravity of aggregate contains good quality, and at the same time low specific gravity aggregates are weak and permeable. Normally, the specific gravity value of aggregate lies between 2 to 3, which is used in construction works. The specific gravity value show the quality and the strength of the materials. Then, specific gravity nga daw, yung value nito ay nagpapakita ng quality and strength of the materials. Makikita dito sa picture na to yung formula nung specific gravity. May ASTM bulk specific gravity, SSD bulk specific gravity, apparent specific gravity. And then next, bulkage of aggregates. Volume of aggregates will change when it's subjected to moisture, called bulkage. When the moisture content is present in the sun, it's form a thin film around each particle that make adjusted particle push a little way from them. This change make overall volume of the sun increase. The bulking sun is the range between 20% to 30%. For the coarse aggregate is minimal. Bulk density is the ratio between dry weight aggregates to saturated weight of aggregates in kilogram per liter. Makikita nga natin dito yung sa pagkakaroon ng moisture, sa bulking sand daw ay nag-range siya sa 20 to 30%, and then sa coarse daw, coarse aggregate is minimal. And then sample nito yung buhangin. Pag nalagyan ng tubig, makikita natin mamasa-masa na parang lumalaki yung volume ng sand. And then sa coarse aggregate, hindi naman siya permeable katulad ng alan ng stone na pag ng tubig, hindi siya lumalaki yung size ng stone. And then the bulk density of aggregate is dependent on the compaction grading of aggregates in concrete. Kaya makikita nga natin dito sa may picture dito sa yung table na to, yung pag-decrease ng volume of sand and yung pagtaas ng moisture content of the sand. makikita natin dito yung tatlong klase ng fine aggregates na inano dito sa may graph. And the next, voids. The presence of space between aggregates particles is called void. The saturated aggregates volume will change due to the presence of voids. Dito makikita natin sa picture yung voids nga daw. Ito yung spaces between aggregates. Makikita natin dito sa yung poorly graded, ito malalaking spaces siya. Wala siyang nakalagay. Dito naman sa well graded, may mga maliliit pang aggregates dun sa malalaki. Parang sample na tong malalaki tong bilog na to, yung coarse aggregate. And then yung sa yung maliliit naman, ito yung mga fine aggregates na pillar siya dun sa may ng coarse aggregate. And then next, gradation and specification ng aggregates. Gradation is the distribution of different size stone comprising aggregates by percent of weight. Gradation is determined by filtering an aggregate through successively smaller sheaves and measuring the weight retained on each sheet. Fine content, negative 200 sheet or smaller than 0.003 inches is determined by washing the aggregates to separate these fine materials from the larger piece. Makikita natin dito sa picture na to na yung malalaking parts ng coarse aggregates ay matitira dito sa may taas, and then yung mga fine aggregates maliliit ay mapupunta sa baba. Bali maseseparate yung dalawang sizes ng aggregates. And then aggregate specification have an allowable range of different stone size expresses percentage of the total weight of sample. And then next, ito makikita natin dito sa table na to yung iba't ibang sizes nung yung salaan na sa 1.5 inch ang matitirang weight ay 0, yung percent naman 0 din, and cumulative percent passing 100%. Sa 3.5 inch naman 49 grams 4 grams sa titirang percent mareretain dun sa may salaan, and then 95.1 yung sa pinakababa yung masasala. And then sa number 4, 204 grams yung cumulative weight retained, and then cumulative percent retained ay 20.5, and then yung percent 79.5. Bali yung sample pala dito nakikita natin 5.5 5.8 gravel. And makikita natin yung mariretain nga daw dun sa gravel dito sa number 4 sa taas ay 20.5, and then yung finer yung matitira tatagos dun sa may sheet na nakabase dun sa may side sheet designation ay 79.5. Sa number 8 naman 439 grams weight, and then yung percent na ma-retain na gravel ay 44.2, and then yung finer gravel ay 55.8. And then sa number 16 573 ma-retain na weight, and then yung percent ah, yung mareretain ay 57.6 yung sa taas, and then sa baba yung 42.4 yung finer, and then yung sa number 30 743, and then yung sa percentage na mareretain 74, bali malaki na yung mareretain dun sa ano, and then yung finer na yun, yung mapupunta sa baba ay 25.3. Bali makikita nga natin dito sa table, pag palaki ng palaki yung designation ng ship, lumalaki yung mareretain na weight, and then yung percentage ng na mareretain o yung mapupunta dun sa may taas na pinakita ko kanina, dun sa dito sa may picture na to. Bali ito yung matitira dito yung sa taas, coarse, and then yung sa baba yung finer, yung magpapass through dun sa sieve. And then dun na po nagtatapos yung aking report.
Okay, so for the next property of aggregates is the composition. So it is important to identify or determine the composition of the aggregate because, as we know, aggregates contain different chemical particles that may react with the cement, and this results to the formation of cracks on the concrete surface. So it is important that we test the composition of aggregate to ensure that such kinds of particles are not present in the aggregates. Next property is size and shape. So the size and shape of the aggregates impact the strength and durability of the concrete. So when we use large size aggregates, this affects the workability of concrete. Therefore, the maximum aggregates that we must use should not be less than 20 millimeters in reinforced concrete. And we must use the largest coarse aggregates visible for the structure in preparation of economical concrete mix. So, Indian Standard Code suggests that the following recommendation to decide the maximum size of coarse aggregate to be used in plain cement concrete and reinforced cement concrete mix. So the maximum size of aggregate should be less than 1/4 of the minimum dimension of the concrete member, 1/5 of the minimum dimension of the reinforced concrete member, and the minimum clear spacing between reinforced bars or 5 mm less than the minimum cover between the reinforced bars and form, whichever is small, for heavily reinforced concrete members such as the ribs of the main bars. Next property is the texture of the aggregate. So the surface texture of the aggregate can either be smooth, polished, or rough. So the rough surface texture of the aggregate is good for developing higher bondage between other ingredients of concrete. So this increases the strength of the concrete. Next one is the porosity and absorption. So the porosity, so this is the formation of pores in the rocks. So pores form in rocks due to air bubbles. So we have porous rocks, so these rocks contains pores. And for the water absorption, it is defined as the difference between the weight of very dry aggregates and the weight of the saturated aggregates with surface dry conditions. And then these different conditions, we have different conditions depending on the amount of moisture content in aggregates. So number one, very dry aggregate. So it means that it has no moisture at all. And we have dry aggregate. So dry aggregate contains some moisture on its pores. And saturated surface dry aggregate, the pores are completely filled with moisture, but the surface has no moisture at all. And we have moist or wet aggregates. So this is both pores and surface are filled with moisture. And then for the fineness of aggregates, so this is another property of aggregate. So the fineness denotes the particle size of the aggregates. So high fineness value means the aggregate is coarser, and low fineness value means the aggregate is finer. So if we use a more fine aggregate, or the aggregate has a very high fineness value, so it may form cracks on the concrete. So to test the fineness of the aggregate, we use the sieve analysis test. And the next one is the surface area of aggregates. So for the surface area of aggregates, so the surface area of fine aggregate is higher than the surface area of coarse aggregate. So the specific surface increases with the reduction in the size of aggregate particle. So specific surface area is the surface area per unit weight of the aggregate. Next one is the deleterious material. So it affects the bondage of the concrete ingredients, resulting in reduced strength and durability of the concrete. So deleterious materials may cause one of the following effects. Number 1, to interfere hydration of cement. Number 2, to prevent development of proper bond. Number 3, to reduce strength and durability. And number 4, to modify setting times. Next property is the crushing value of aggregates. So crushing value of aggregates gives a relative measure of resistance of an aggregate to crushing under gradually applied compressive load. So it is helpful to determine the crushing value of the aggregate to find the compressive strength of it. So it determines whether it is suitable for the concrete work or not. So as you can see here in the picture, we have here the aggregate crushing value test procedure. So the strength of the aggregate is determined by preparing a cylindrical shape specimen with a size of 25 millimeter in diameter and 25 millimeter in height. So after the specimen is prepared, or the test sample is prepared, the cylinder will be subjected to compressive stress. So here we have the plunger, and then the aggregate here and the bottom. And then next one is the impact value of aggregates. So this is used to find the resistance capacity of aggregate from sudden impact applied on the aggregate. So to test the impact, to determine the impact value of the aggregate, we use this impact machine. So this impact machine, we put the test sample on the cylinder test cup, and then a tamping rod is placed above the cylinder cup, and the tamping rod crushes the sample. So we measure the before and after weight of the sample using the weight balance or weigh balance. Next one is the abrasion value of aggregates. So abrasion value of aggregates measure the resistance of the aggregate to wear when it is rotated in a cylinder along with the abrasive charge. So as you can see here in the picture, we have here the Los Angeles machine. So this Los Angeles machine produces abrasive action using a standard steel ball. So the standard steel ball is mixed with the aggregate, and it is spun in a drum in a specified time and in a specific number of revolutions. So after the procedure is done, we determine the percentage of wear of the sample aggregate due to friction with the steel balls. So the percentage or the value that we get there is called the Los Angeles abrasion value.
List of test methods for concrete aggregates. Grading or sieve analysis. This test determines the particle size distribution of fine and coarse aggregates. So dito sa grading and sieve analysis, yung different sizes ng sieves ginagamit. Then kung ano yung magiging outcome ng sieve, like yung fine to coarse, meron silang corresponding usage kung saan sila magandang gamitin. Tsaka dito din malalaman kung saan ba sila magkakaroon ng magka-cause ng trouble. So, well-graded aggregates prevent the segregation and bleeding of fresh concrete. It also reduces the void content, resulting in a stronger, more durable, more economical concrete mix. It reduces the chance of getting air pockets in the cement mixture. So, yung well-graded aggregates, syempre, kaya tayo gumagamit ng sieve para maihiwala yung fine particles sa coarse particles. So, yung coarse particles kasi nagkukos siya ng air pockets kasi meron siyang tendency na magkaroon ng gap in between them, which is na hindi makikita sa fine aggregates. So, pag sa fine aggregates kasi, parang every void space na makikita niya is pwede siyang makalusot kasi sobrang fine nga nung texture niya, sobrang pino niya. So, syempre, lesser air pockets can cause stronger concrete mix, syempre mas durable and mas economical concrete mix. So, more durable siya kasi yung air pockets, if ever magkaroon sila ng isang line ng air pockets, walang bond dun sa air pockets na yun. So, mas madali siyang masira. So, next. Materials finer than 75 millimeter sieve. Determination of quantity of materials finer than 75 millimeter sieve, which may be composed of clay particles and clay coating. Excessive amounts of materials will result in poor bonding between aggregates and cement paste. Foreign elements may deteriorate the bond between elements present in the concrete mix. So, yung sieve na merong finer texture ng 75 millimeter, yung mga nasasala niya is basically more on clay particles or clay coatings na lang. So, yung clay, alam naman natin yung clay or putik, pagka na tuyo siya is sobrang dry niya and sobrang dali niyang mag-crumble. So, if ever meron kang concrete mix, then meron kang clay na present, syempre, yung clay na yon is magkukos siya, pag natuyo yung concrete mix mo, magkukos siya ng damage kasi hindi maganda yung bond ng concrete mix pag meron siyang clay particles na na present dun sa mixture. And kaya tayo gumagamit ng fine sieve para matanggal yung clay particles na yun. So, next. Standard specification. So, sa fine aggregates, 3% max for structural and pavement concrete, 5% max for all other concretes. So, yung sa parang maximum amount ng clay particles or clay coating yung standard na makikita. For example, sa structural or pavement concrete, 3% lang yung maximum dapat na makita na clay content. So, manufactured sand, 5% and 7% respectively. So, manufactured sand, syempre meron siyang basically meron siyang mas madaming clay, pero yung manufactured sand kasi is maganda na yung quality niya para gamitin sa concrete mix. So, yung mga clay na present is hindi na siya basically makakaapekto. So, coarse aggregates. So, coarse aggregates is 1% maximum, but 1.5% maximum is allowed if the material is free of clay or shale. So, yung 1% na maximum na makikitang clay content or sa 1.5% if yun nga clay free siya na coarse aggregates kasi yung clay nga is nasasala siya dun sa 75 millimeter. So yung coarse sieve niya is syempre malalaglag na yung mga particles dun. So hindi na siya sasama. clay lumps and friable particles. So, determines the quantity of soft and easily breakable materials present in the aggregates. So, yun nga, sa same ng sinabi ko kanina, yung clay is nagkakos siya ng damage if ever mahalo siya sa concrete mix. So, yung soft, yung concrete mix kasi, kagaya na lang sa pag ginagamit siya sa paso. Alam naman natin na ang paso is madali mabasag. So, konting tuktok lang. Siyempre, if yung cement mix natin is ganun siyang kabilis mabasag, is ibig sabihin, hindi maganda yung quality. So, ibig sabihin, pag hindi maganda yung quality, ibig sabihin, may clay na present. So, sa fine aggregates, 3% maximum kasi yung finer aggregates niya is lahat yung wala siyang andun kasi yung fine aggregates nandun kasi yung basically yung mga clay particles or clay coating dun siya madalas makikita. So 3% maximum, mas maganda kung mas matatanggal yung clay particles. So coarse aggregates 5% max for structural pavement concrete and 10% for other classes of concrete. So yung sa kagaya nga nung sa coarse aggregates, yun nga yung mga clay particles niya is nasasala na or nalalaglag na dun sa next na sieve. So basically mauubos na yung clay na meron siya. So mas madali siyang maiiwasan. So abrasion loss. Measure the extent of degradation of coarse aggregates using the Los Angeles abbreviation machine. So, low aberration loss manifests as structurally sound, tough, durable aggregates. So, yung sa aberration, yung aberration kasi, yung present na cracks sa isang concrete or sa isang pavement. So, let's say, sa kalsada, yung meron kang maliit na crack and yung structural sound niya is kung yung crack na yun ba is mabilis siyang kakalat or mas mabilis siyang dadami through time. So, structurally sound, yung crack mo is mananatili siyang ganun, hindi siya kakalat. So, yung toughness and durability, syempre, mas matibay yung concrete. Mas mabilis may iwasan yung pagkalat ng cracks. So, soundness loss estimates the soundness of aggregates when subjected to weathering action in concrete or other application. So, yun. Yung cracks, yung kagaya nung kanina, yung cracks na yun is nakukuha din siya ng concrete sa weathering. So, ang isang pinaka-common dito ay yung ang isang pinaka kung saan mo makikita ko yung malalaking damage is dun sa snow or sa pag-drop ng temperature below freezing point. So let's say sa snow, yung concrete mo is syempre makakapasok dun yung tubig. And if yung tubig na yun is mag-turn into snow or ice, mag-i-expand yun. So, yung cracks or kahit mga micro cracks dun sa concrete, pag nag-expand yung ice dun sa pagitan nun is tuloy-tuloy siya or mas lalaki yung crack niya. And over time, pag naulit yun, dun mas lalaki na or mas lalala yung cracks. So, low soundness loss indicates toughness and durability of aggregates. So, syempre, pag sinabi mong mas mababa yung soundness niya, or less cracks or less damage, masasabi mo na durable and tough yung concrete kahit na hindi siya magde-degrade over time. Organic impurities. Determination of presence of injurious organic materials in fine aggregates used in cement, mortar, or concrete. It affects the hydration of cement, which results in low strength or low strength development of concrete. It may contain decayed vegetation, humus, coal particles, and organic and industrial waste depending upon the source. So, dito sa organic impurities, syempre hindi naman may iwasan na merong, let's say, mga dahon or decayed na dahon. Yung mga tuyong dahon or let's say, yung mga coal particles na masahalo doon sa cement mix mo. So, yung pag mayroong organic particles doon, syempre, mag-iiba yung parang absorption ng tubig na doon sa concrete mix mo. For example, pinakamagandang example is yung coal. Yung charcoal kasi is maganda siyang absorbent ng water. So, kung yung water na yun, imbes na sa concrete siya mapupunta, isihigupin lang siya ng coal, is parang hindi gaganda yung concrete mix mo and dun magsisimula yung iba't ibang um, iba't ibang damage or ano ba? Dun, dahil dun sa coal na yun, yung concrete mo is masihina siya or hindi na siya magiging tough. It may contain, text. Specific gravity and absorption. So, specific gravity, SG, value is used in the calculation of volume occupied by the aggregates in concrete mixture. So, sa concrete mixture, let's say meron kang area na i-fill up and yung concrete mixture mo is ganito yung required na kailangan. So, let's say sa cement, meron ka ng cement, meron ka ng water. So, yung using specific gravity value, madedetermine mo kung ilang aggregates ba yung meron or kailangan mo dun sa area na yun na kailangan mong fill upan ng concrete mix. Aggregates with low SG often exhibits poor performance in concrete mix. So, let's say, yung mga magagaan na aggregates is ibig sabihin pangit siya para dun sa concrete mix. Kasi, let's say, yung dust or versus sand. So, syempre, yung dust, magaan siya and medyo weak yung structure niya kasi kahit sa wind is nadadala siya. And unlike sa sand na meron siyang yung bigat niya is sakto lang para doon sa concrete mix. And doon makikita yung toughness nung heavier specific gravity kaysa sa higher specific gravity. So, bulk density. So, covers determination of bulk density and void between particles of aggregates in a compacted or loose condition. So, itong bulk density is masasabi mo siya as yung air pockets or void pockets dun sa concrete mixture mo. And yung concrete mixture mo kasi is, kagaya ng sabi ko kanina, if mas madami siyang air pockets or void, mas hihina yung integrity niya. Mas madali siyang masisira kasi yung dahil doon sa air pockets na yun, medyo humihina yung bond ng concrete mixture. So, bulk density and percent voids between aggregates particles are used in determining mass or volume relationship. So, madedetermine mo kung yung mixture mo is if magaan yung mixture mo para dun sa area, ibig sabihin meron kang air pockets na present dun sa mixture mo kasi pag may air pockets ka, so yung mass ng air syempre is 0. So yung mga air pockets mo na hindi na fill up is mababawas siya dun sa overall na weight or mass ng concrete mo. Unlike if matatanggal mo lahat ng air pockets or void mo, syempre magiging compact siya. So, mag-a-add up lang ng mag-a-add up yung mass mo. Kasi wala kang ika-count or bibilangin na zeros. Zero weight. So next, potential alkali reactivity. Test method for potential alkali silica reactive of aggregates. So it evaluates the potential reactivity of siliceous aggregates with the alkalis in Portland cement. So dito sa potential alkali reactivity, um, ang ang concrete kasi is sensitive siya sa acidic water. So, if yung acidic water kasi is na bumabad sa concrete, unti-unti siyang natutunaw or unti-unti siyang kinakain ng acid. Kasi, yung, syempre, yung acid is kumakain siya ng iba't ibang bagay. So, yung acidity na yun, pag kumain siya dun sa concrete, syempre, masihina yung concrete. Over time, mauubos yung concrete mo na magkakos pa ng further damage. So, test method for potential alkali reactivity for aggregates ASTM C1260. A means of detecting the potential aggregates intended for use of concrete undergoing So, next. Here are the standard specification for potential alkali reactivity. Aggregates is innocuous, so less than 0.1% of at 16 days. So potentially reactive is 0.2% at 16 days. So yung aggregates mo is mas mababa yung as yung acidity niya is syempre mas hindi siya magiging harmful para dun sa concrete, and mas mababa yung damage na mangyayari sa kanya. Mas mababa yung damage na mangyayari sa kanya, syempre mas matagal siyang ma-deteriorate. So next,